Hello, Mrs. Middleton here to go over soil composition and properties. You'll have a lab looking at these elements, and you'll probably have to bring in some dirt from home to analyze. So buckle up, because these are some things you definitely need to be aware of. In the previous presentations about soil, you learned about soil horizons. Within each layer of soil, the composition might be different because of what is there. For example, in the A horizon, you have organic material, which is going to make the soil darker and typically more varied in particle size, whereas in the B horizon, you have more minerals, notably clay, which is red in color and the smallest particle size. The particle size and composition of each soil horizon can affect the porosity, permeability, and fertility of the soil. Let's first go over the different types of soil, then what exactly porosity, permeability, and fertility is. The three main particles that make up your soil is sand, silt, and clay. Sand is obviously the largest particle size, and clay is the smallest particle size. Knowing what particle size is dominant in your soil is helpful depending on what you are trying to do in that area. If you need the soil to drain well, you might need to add sand particles to your soil. In the image you can see that because sand particles are large, there are bigger spaces between the grains, allowing water to move through easily. If you have a landfill that you don't want fluids to exit, you may use clay as a base for your landfill. The way that clay particles lay against each other does not allow for fluids to move through quickly. If you are farming or building a house, you don't want too much of any one type of particle size. Although clay holds water for thousands of years, the particles actually expand and contract with the addition or subtraction of water. The school I taught in down in Virginia built a new building, but found that they had to take the clay soil that would have been beneath the building and add other particle sizes into it so that the ground wouldn't expand and contract beneath the building every time it rained. Porosity and permeability is usually something that students confuse. Although these vocab words are tied together, they are not the same thing. Porosity is the space between each particle. As we said in the last slide, sand, which has a greater grain size, typically is more porous. Permeability is the ability for soil to let water move through it. Clay is considered non-permeable. You may also hear that term as we talk about groundwater. There are certain rock, like igneous rock, created from flowing magma that is impermeable. Water can't get through it. While limestone, a sedimentary rock that is more porous and can become more porous over time, is considered permeable rock. This image is the soil texture triangle. It's one of my favorite graphs just because I think it was cleverly put together. This diagram allows for the identification and comparison of soil based on their percentage of clay, silt, and sand. Obviously, for farming and fertility of soil, you don't want just one type of particle. A good mixture of the particles, or a loamy soil, is best for growing plants. If it holds onto water flowing through the ground, but doesn't hold onto it forever, drowning the roots, that's a good thing. Remember, water holds materials that are necessary for plants, so the right type of soil will help a plant get the nutrients it needs. Now, to use this chart, it might look confusing, but once you practice with it, you'll see that it is brilliant. Let's say I give you a soil and there is 30% sand, 30% clay, and 40% silt. When you look at the triangle and the numbers on the outside of it, the number of sand and silt are tilted. They are tilted that way because they are showing you the lines to follow. So for the soil example, we have 30% sand. I go to 30% and I follow that line. For my freshmen, I make them highlight the line. I'm going to go to clay next. There is no set order for this. My clay is also 30%. I find 30% and I follow its line. Now at this point, you can tell what type of soil you have because when you add up the percentages, you will always get 100%. Regardless, my silt for this soil was at 40%. Where they all meet, that will be your soil type. Clay loam isn't a bad soil for farming. It might hold more water. My dad is a farmer, and you guys might be aware that there is a good amount of clay where we live. My dad's fields at times have problems with drainage after a big rain, but otherwise, because it's a type of loam, it produces excellent produce. There may be times where you see a soil triangle like this. Notice that the numbers are not tilted to show you which line to follow. Instead, you will have the arrows on the outside pointing to the direction of the corresponding line. Just pay attention to the soil triangle you get. We will practice using one in class. There are several types of tests you are going to do in class in the upcoming days. There are chemical, physical, and biological properties of soil that can aid in a variety of decisions, such as irrigation and fertilizer. Last year during the soil lab, I was testing my own soil to see what I should grow around my house. These tests might not seem useful now, but once you own a home, they're excellent to be familiar with. Some of the chemical tests you'll be doing is looking at how much nitrogen, phosphorus, potash, or potassium, and the pH of soil. These are helpful in that you can determine if you should add a nutrient that will help your soil. Or pH can be a huge indication of what you can grow. If you have pine trees at your house, you'll notice that grass doesn't typically grow well under them. That's because the pine needles that fall to the ground make the soil more acidic, too acidic for certain grasses. The field test is exactly what it sounds like. You will be given a dichotomous key which will guide you through how your soil feels. The way the soil responds to certain manipulations of the soil will give you an indication of what type of soil you have. This is a physical test we will do in class. For biological testing, you might look at how much CO2 is in the soil, or even look at what microorganisms and macroorganisms are in the soil. Worms can mean that your soil is healthy. We won't be doing this test in class. That's all for now on soil. Remember, you will probably need to dig up some soil soon because we will have a lab on this material. If you had questions about anything shown in this presentation, contact your teacher. Thanks and have a good one.